on the nature of the CX bond. On the nature of the CX bond means, let us take another one more example of the nature of CX bond, means between the carbon and the halogen bond. We all have studied that this bond that is being present between this carbon and halogen, that is chlorine, bromine, iodine or fluorine, we all know that all these halogens are quite more electronegative compared to this carbon. So as a result, this bonded electrons will be shifting more towards this halogen atom, and therefore a partial negative charge will be created onto this atom, a delta minus, and onto this carbon a delta plus. Now as I said, partial charges means it is not the charge of Na plus or Cl minus, means it is trying to pull these two electrons more towards itself, therefore there is a partial charge we are talking about. Now let us see that by the help of this, as we are saying, by the help of this type of bond cleavage, we can make some preparation of haloalkanes. Under that, the number one is from alcohols. How the things will be done in alcohol, as we know that the general formula is ROH and HX is the halogen acid. So what it will be forming? It will be forming RX plus H2O. Over here ZnCl2 acts as a catalyst. So this is how one haloalkane is being formed from alcohols. The next one is from another one we can show by the help of thionyl chloride, SOCl2. Over here what we can see, R and Cl combines and from halogen or haloalkane and SO2 and H2O. As SO2 and H2O both are in the form of vapor, so we will be getting this haloalkane as in the form of a pure form. And this is the best lab method. This is the best lab method. Remember? Now, apart from this, you will be finding in the book more PCl5, POCl3, such type of reactions. You can go through them. But the most important thing of today is free radical mechanism. What is free radical mechanism? The most important thing over here is free radical mechanism. In the free radical mechanism, you can clearly see, or we always in the class 11 we have studied that, take for example Cl2, under diffuse sunlight it forms Cl and Cl, a free radical, and we all know that the free radicals are highly reactive and they have a very strong tendency to break the single bonds. Now let us see our initiation process. This is the initiation step, this one. After this, with one of these free radicals, I am combining a methyl or a ethane, that is a alkane. What will happen? This will always have a tendency to break this bond, and as a result we will be getting one free radical and it will be combining into CH3Cl. This is known as propagation step, means elongation. After this, you can also see that this free radical, that is CH3, which is present over here, it will be combining with another Cl2 molecule, and as a result this time what it will be happening, it will be breaking one Cl molecule and it will be changing it into CH3Cl, and one of this chlorine will be again be forming a free radical. Now after this step, in the last step what you will be finding, that is the termination step. One more thing, this is also known as homolytic cleavage, means similar type of atoms are present and both the electrons are being shifting towards each other. In the termination step you will be finding two free radicals can combine to form a Cl2. You can also see CH3 and CH3 combine to form a ethane molecule, or you can see to form CH3Cl.